DIF-FFT, what happens? If you see, total factor has moved. Yeah, this one is in the normal order. This would be in the decimation order. If you have understood the DIT-FFT, now you would be able to calculate these values. X0 is nothing but this is coming over here, this is coming over here, x0 plus x1, and then x1 equals to x0 minus of x1, and then after this addition is done, then we are having this multiplier of, with the total factor. Okay, over there before the addition we were multiplying with the total factor, right? So before the addition we were having this multiplication with the total factor. Herein, after the addition is done, so then we go for the multiplication with the total factor. Okay, so similarly 4-point DFT mein we will be having this yeah, in 4-point DFT initially we have to do the 4-point DFT, then we have to go for the 2-point DFT. Okay, similarly in the 8-point DFT, first stage would be the 8-point DFT using the FFT method, then 4-point, then 2-point DFTs, 4 2-point DFT. Okay, so in the DIT FFT it was first 2-point DFT, then 4-point DFT, then 8-point DFT. Here it would be 4-point DFT, sorry, 8-point DFT, 4-point DFT, 2-point DFT. Okay, and your input order it would be in the normal order and the output would be in the reverse order. Now herein, if you see the same thing, we have put it into the table. So if you see the output, it is in the reverse order. It is in the reverse order. Now while performing the IDFT, your xn it is in the reverse order because we are using the DIF-FFT method. DIF, the reason remains the same. When we are doing the xn to xk, our xk is in the, that means the output it is in the decimated form. So IDFT mein our output is xn, so this xn would be in the decimated form, and again there will be a multiplier of 1 by 8. Okay. So why FFT? Because in DFT there are complex multiplications which are equals to n square, and there are complex additions of n multiplied by n minus 1, where n is the length of the signal. Okay. However, in radix to FFT, the complex multiplication it reduces to n by 2 log 2n, and complex addition it reduces to n log 2n. So there are two methods of performing IDFT. So I have already told you xk as the, we take xk as the input, we take the conjugate w conjugate n, then we get the output in the reverse order or the normal order, whatever we talk about. So DIF FFT it would be in the reverse order, DIT FFT it would be in the normal order. However, there is another method where we can perform it in this way. First we take the conjugate of the output. Okay, so we get xk, we find out xk conjugate. Then we perform FFT to get x dash conjugate n. Then we again perform the conjugate of x dash n to get x dash n, and then we calculate xn as 1 by n multiplied by x dash n. However, if you see, we have to take conjugates two times. Why to spend so much of time? So what we can do, we can use this method, take xk as the input, then you take the conjugate of the total factor values, and whatever the output you are getting, you just rearrange it according to the whether you are applying the DIF-FFT or DIT-FFT. So there are some numericals. Calculate 4-point DFT. So the signals are xn equals to 0, 1, 2, 3. So this can be broken down into 0 to 1, 3 in this order, and this is our values. So W01 is 1, W04 it is 1, W14 it is minus j. So you just put the values, calculate this, and you get the value. Okay. Now we can take this thing over here, and if we perform inverse Fourier transform, inverse discrete Fourier transform, we get back our original signal. Okay. So then this I have already told you about the LTI systems. So if you have a xn, yn, output will be yn equal to xn conjugate of hn. So how you can get it? You get that, do the DFT of xn, you do the DFT of hn, you get xk hk. So you get yk, which is equals to xk multiplied by hk, and after that you perform the IDFT to get the yn value. So this is what it is being written. So this we will start in the next class. So what I would say, request you, you perform this. Still, do we still have time? Yeah, we still have 15 minutes time. So please perform DFT of this signal by this matrix method, basic DFT method, and then perform this with the DIT method and DIF method, DIF-FFT.